above 100 degrees Celsius in the presence of a catalyst and in excess of pure oxygen gas. These to convert the elemental components into gaseous oxidation products, which are then quantitatively determined by means of a detector. In our portfolio, we can find 3 different elemental analyzers. We can start from the left. You can find the EMA502, that is developed all-in-one solution for the determination of carbon, hydrogen, nitrogen, sulfur, and oxygen. On the right, there is the NDA702 for the analysis of nitrogen and protein following the Dumas combustion method. And in the middle of the screen, there is our CN802, today's focus, that is equipped with the high-sense IR detector for the determination of carbon and the TCD detector for the determination of nitrogen content in the sample that we are analyzing. The CN802 is a robust and flexible combustion analyzer that works in accordance with official reference method in many industrial sectors. In particular, we use this instrument in agriculture, environmental field, and food and feed, and of course in the chemical sector. And this instrument lets the operator to analyze the total carbon, as we said, the total nitrogen, the total organic carbon, so the TOC after acidification, the total inorganic carbon, the TIC by different, and of course we can calculate the carbon-nitrogen ratio inside the sample. The CN802 is designed for high throughput laboratory because it gives results in 3-5 minutes, and it is equipped with the electronic autosampler that has up to 117 positions. We are talking about a micro and macro element analyzer in just one solution, because thanks to the new detector that we will see in detail with Roberto, we can analyze both high weights and volume, very important for those inhomogeneous and low concentration inhomogeneous samples, and those samples that have a low concentration of carbon content, as well as small weights. Then a great flexibility is granted by the possibility to analyze both solids and liquid samples, perform TOC determination, all of it with matrix independent results, and with a very simple routine maintenance. Then the laboratory has the versatility to choose between helium and argon as a carrier gas. We will see later the benefit of using one carrier gas instead of the other, and the possibility to easily manage the instrument and set all the parameters with the user-friendly CN software that provides the operator with all the information, data, results, and so on at a glance. And last but not least, as you can see from the picture, thanks to our Well-Performance Cloud platform, it is possible to real-time monitor and manage the CN802 analyzer anytime, anywhere, how, using, as you can see, tablet or a smartphone, and of course, laptops. So thank you for the attention. I leave the stage to Roberto, and with him we will see in detail our CN802 model year 2024, and later the application in which we can use this instrument.
Hello everybody. Today we present the new high-sense IR detector. The innovation is a new detection system called high-sense IR detector that can now cover an extremely wide carbon concentration range, starting from very few ppm. A second IR detector has been added that works simultaneously to the previous one. So from the software, you won't notice any difference because the software shows the most appropriate graph selecting between two different IR detectors. And the results is that the detection limit improves by an order of magnitude, opening up to new applications. And how is it possible to analyze both micro and macro sample weight? We can go over the meaning of absolute elemental content. If we look at the new working range expressed as absolute elemental content, and we take carbon as a reference, it is clear that it is now possible to cover an extremely wide concentration range. So a minimum detection limit of 0.003 milligram of absolute carbon means that now it's possible to measure extremely low carbon concentration. For instance, 20 milligram of a fiberglass sample with a carbon content of just 0.04%, or even wastewater with a carbon content of about 50 ppm. On the other hand, a maximum carbon content of 150 milligram of absolute carbon means that now we can measure really high sample weight and volume for samples that have inhomogeneities. For instance, we can measure 200 milligram of an organic sample with a carbon content of over 50%, or even 1 gram of a mineral sample like a soil. This new detection system enables to perform a single calibration that covers the entire working range. So it's possible to analyze different samples with different elemental content, one after another, in the same analysis run, because elemental analysis provides matrix-independent results. The new software that is we provide free upgrade for that is really a powerful tool that controls and provides all the important information and has been enriched with the new features like the 21 CFR Part 11 option. So, which methods are available for measuring solid samples? It is important to mention that the sample preparation is very, very important. So even if we are dealing with a macro analyzer, the samples must be well homogenized. And then the weighing accuracy is an essential part of the analytical process. When weighing large sample amount and standard analytical balance with 5 or also 4 digits is sufficient. The second preparation of solid samples is quite easy and consists of weighing the sample into conical shaped tin foil and place it into the autosampler of the CN802 that now became totally electronic, so you don't need any more compressed air for the movement. It should be noted that in the combustion zone, the oxidation of the wrapping material, so the tin foil, generates a short time temperature up to 1800 degrees that really help to guarantee the complete combustion of macro samples. And which methods are available for measuring liquid samples? We can go over the methods for liquids. The first is a method that we are all used to. That is to use a tin foil plus the super absorbent powder. So the use of super absorbent powder, the role is to absorb the water and solidifies the sample, facilitating the closure of the tin foil without any loss of the samples. You can see from the video that we can directly dose the sample on the powder. So then the tin foil is wrapped and packed and directly placed into the autosampler. The second method is to use tin cups that gives the possibility to measure up to 0.5 milliliter without the need of the powder. As you can see from the video, you can directly dose the sample inside the tin cups. And the advantage is that you can measure long routine series in the same analysis run with solid samples. Tin cups can have different heights and dimensions depending on the needs. So a new disc with deeper holes have been created to accommodate these higher capsules. The third method is an innovation developed by our R&D department that is the direct injection of the sample in the combustion area by means of a syringe. So the analyzer can be equipped with a manual dosing liquid sample kit that can be easily mounted in the analyzer in about 5 minutes by removing the autosampler. So the sample is through an injection port, you can directly inject the sample inside the combustion tubes. You can see from the video that the operator can take the sample with the syringe and then through an injection port with the septum directly inject the sample in the combustion area. So the result is, of course, that we can increase the sample volume up to 1 milliliter, but also that we can really reach high sensitivity of very few ppm. So this high sensitivity is possible because by using the syringe, we are working in a very clean way without the use of a tin that generates a blank values. So the result is that the detection limit improves by 2 orders of magnitude. So now with this new system, we are working in a range typical of water samples. And which methods are available for measuring TOC, total organic carbon? Carbon can occur in a large variety of compounds. This is why carbon speciation is essential for a complete characterization of environmental samples. A first important distinction can be made between total inorganic carbon and total organic carbon. TIC, so inorganic carbon, are non-hazardous compounds present in almost all soil and rock formation and have a very low environmental impact. On the other hand, TOC, the total organic carbon, can have a biological activity, the presence of toxic compounds, the formation of complexes with heavy metals, and also the formation of methane, for instance, important in landfills management. So the TOC represents a rapid, reliable, and accurate method for measuring pollution as a result of contamination through anthropogenic activities. We measure total organic carbon in agreement with international regulation by following the direct procedure. According to this procedure, the total inorganic carbon TIC is previously removed by treating the sample with acid. And then TOC is detected directly through a single determination in the elemental analyzer. So how do we perform the TOC determination? At first, the sample is weighted into silver foil and placed on developed Teflon plate. The sample cannot be acidified in tin foil directly because the strong acid will damage the thin packing material. Then, as shown by the video, you have to carefully add drop by drop the sample with diluted hydrochloric acid until no bubble formation is visible. So you can wait also at least 4 hours just to be sure that all the inorganic fraction have been released. Then you have to dry the sample before combustion by placing the sample in the plate for TOC, selecting a temperature from 40 up to 170 degrees. And at last, you can close the capsule tight and place the sample into the autosampler, and you will obtain the results expressed as TOC. So our CN802 analyzer is the ideal solution for a routine long-term determination of TOC in any kind of sample matrix. And the reason is thanks to all the solution, numeral technical solution that are designed to tackle the possible issues caused by the routine measurement of aggressive sample. In fact, when we measure in TOC, we are introducing in the analyzer large amount of chlorine that can be dangerous for your detection system. So the main solution are, of course, the use of silver foil, acid-resistant foil for the sample preparation, the use of a ceramic crucible inside the combustion tubes that is break-resistant material and avoid the sample residues enter the combustion tubes. Then a very important device, a Peltier cooler, that is a maintenance-free physical trap able to condense about 99% of water and also impurities. This device also enables to work in routine with liquid samples without the intervention of the operator. And last, there is a new halogen scrubber that is needed to trap acid vapors and halogens. So all these solutions help to protect the detection system and to have a really stable analyzer dedicated for the routine measurement of TOC. And what types of sample can be analyzed? An important application field is agriculture. So it's possible to measure samples like soil, sediments, clay, plant, and leaves. The study of organic matter is of great importance for the development of new land management techniques. Moreover, there are very common parameters such as the carbon-nitrogen ratio that determine the correct balance of nutrients in soil and sediments, for instance. In this example, we measure, for instance, 300 milligrams of different samples with using argon like carrier gas. Another important application field are fertilizers. So the determination of carbon and nitrogen in fertilizer is important, especially for manufacturers that can check the raw materials and then the finished products, so as a quality control. Moreover, the study of carbon and nitrogen in fertilizer can be used for customized fertilization campaign. Fertilizer, as reported in this example, can have different amount of carbon and nitrogen, and often also inorganic fertilizer are measured that can have a really difficult combustion behavior due to the lack of organic material. In this case, is anyway possible to optimize the combustion of these compounds, for instance, by using vanadium pentoxide that is an additive, an oxygen donor that help to optimize the combustion and optimize the recoveries. One of the main, among the most frequent application fields are food and feed. So it's really, really important to have the nitrogen content and the evaluation of the raw protein content. So it is possible to measure in routine samples like meat, flour, rice, starch, but also thanks to the presence of a Peltier cooler that helps really to condense the moisture and water, it is possible to perform really the routine measurements also of liquid sample such as milk and other samples. In this example, we measured macro sample over 100 milligram by using argon as carrier gas of different, very wide range of food and feed element samples. Again, another important application field is environment. According to the standard, it's possible to analyze different sample matrices like soil, sediment, sludge, compost, and waste, one after another, of samples that have very different carbon and nitrogen concentration range. We can measure these samples with the same calibration because elemental analysis provides matrix independent results. And then also new application born from the improved sensitivity of our CN802 analyzer, because we have implemented the new high sense detection system. You know that TOC in water has become one of the most important parameters used to monitor the levels of pollution. And now the sensitivity of this analyzer allows to measure also wastewater sample, but also some river and lake sample that have a TOC content of about 10 to 40 and also over TOC content. Here, we reported a last example of a wastewater directly measured with directly injection the sample in the combustion area, in the combustion zone. So we injected about 100 microliter and we obtained a very nice repeatability of TOC of a sample that have 50 ppm of TOC. Of course, the sample before determination must be acidified to a pH close to 2, just to be sure that all the inorganic part have been released. Then the sample have been purged with oxygen gas to help the removal of inorganic carbon. And then by using our new kit, the sample have been directly injected into the analyzer. Oh, okay, I thank you for participating to this webinar, and now we can dedicate some minutes to any question about the presentation.
Thank you, Roberto, for your presentation. We collected the 3 questions, and then to the rest of the questions we will answer later. So the first one is how to switch to argon. What are the main difference compared to helium?
Okay, we have to say that the conversion is really quick and simple. First of all, it should be noted that the option of argon is included in the supply of the instrument. So it's not an optional, but it is completely free of charge. After the connection to the new carrier gas, you need at first to flush the analyzer for at least a couple